Okay, so we're in section 4.6. We're talking about modeling direct variation, and many of you are like already on top of it and have an idea. So I have three graphs presented for you. I have a red graph, I have a green graph, and I have a blue graph. And the question is, which line represents direct variation? So let's talk about this. Go ahead and anybody have a thought as to which one might represent direct variation? Yeah, Yuseli, what do you think? He says the green one. Okay, why do you say the green one? Can I ask why? You say what? Say again? Yes, it goes through the origin. That's exactly right. You're actually 100% correct, okay? Graphs that represent direct variation have a very special characteristic, and that special characteristic is that they go through the origin. So the answer is the green one because it passes through the origin. Passes through the origin. So then the question is, well, if a graph passes through the origin, what's the equation of direct variation look like? So we're going to write that part down next. Does anybody remember slope-intercept form? What's slope-intercept form? Y is equal to mx plus b. And my question to you is, what does the b stand for? The y-intercept. And if we're focusing on direct variation for today, Andres, go ahead, say it again. The y-intercept has to be 0. So that gives us this. Y equals mx plus 0. Well, we don't really have to write down the plus 0, right? So we just say y is equal to mx. So this part right here is super, super important. And the m stands for what? The slope, of course. Let me write that down. So your m is equal to your slope. And your m cannot be, who knows what value m is not allowed to be. What's that? 0. M is not allowed to be 0. So this is what we call direct variation. Okay, you guys with me so far? So, oh, that's not my highlighter. Oh, yikes, that looks really ugly. So direct variation, that's the part that we're talking about. Y equals mx. M is the slope, and m cannot be 0. So, in fact, we're only talking about lines that go through the origin, right? They're going through the origin. Okay, so second part here today. The directions is identify whether or not the line represents direct variation. So, is this direct variation? And I'll just put V for direct variation. Is that okay with you guys? Okay, is this direct variation? Here's part A. 4x plus 2y is equal to 0. And part B is going to be negative 2x plus y is equal to 3. I want you to work this out with your partner and to come up with an answer, either yes or no. Let's go ahead here. So you've had a little bit of time to think about it. So for part A, let's see here. Is this one direct variation? Raise your hand if you say yes, part A is direct variation. Let the record show almost 90% of the class has their hands up. And then part B, is that direct variation? Yes or no? Say yes, put your hands up. Put no, put your hands up. Everyone says no on that one. Okay, let's talk about why. How do you determine if an equation, a linear equation, represents direct variation? Yes, go ahead. Y is equal to 0. Oh, the y-intercept is equal to 0. You are right. Now, how do you determine that, though? What do you do? Is there something that you guys did? You put it in slope-intercept form. So, 2y equals negative 4x. So that means y is equal to negative 2x. Is that what you guys got? Yeah. Okay. Does that match direct variation? Yes, it sure does, right? What's the slope of that line? Negative 2. Very good. Let's take a look at this one, though. If you solve and get into slope-intercept form, you got y equals 2x plus 3. Does this match direct variation? No, it does not, because the y-intercept is what? It's 3. What's the y-intercept of this one? 0. Very, very good. You guys, is this making sense to you now? Yeah, it's making sense? All right, cool. Okay. Third idea here. Okay, I want you to do some graphing. So, I'd like you to graph direct variation. Okay, I'm going to give you two graphs. I want you to graph y equals negative 5x, and B, you can graph them both on the same coordinate plane, y equals 3/5 x. Go ahead and take a moment and work with your partner. You can graph both of those on the same coordinate plane. So we'll go ahead and put those right here. All right. It seems to be like all of a sudden we forgot how to graph lines. So I'm going to make sure that we get this part right. Remember, what's the process to graphing a line? Step 1, you need to put it into slope-intercept form. Step 2, you need to apply the y-intercept. Step 3, from the y-intercept, apply the slope. Step 4, connect the lines, right? So what's the y-intercept for this first one here? We do this one in blue. What's the y-intercept? 0. So you should have a dot at 0. And then, what's the slope? Down 5. 1, 2, 3, 4, 5 to the right 1 unit. Now, you can apply the line. Or draw the line. Wow, I did a terrible job there. That's pretty bad. But you guys, you're with me, right? Yeah. Okay, cool. All right. I'll just make the dot bigger. There. There we go. Okay? I know. It's okay. Don't worry about it. Okay, this one, y equals 3/5 x. We'll do this one in a different color so you can see. What is the y-intercept of y equals 3/5 x? 0. So a big dot right there. So I'll put another big dot right here. Okay? Now, I need to go, what's the slope from that point? What's the slope? Up 3/5. 1, 2, 3. 1, 2, 3, 4, 5. Put a dot there, and let's see if I can do a much better job of drawing this one. Yeah, much better job of drawing this one. There we go. Okay, both of those lines are direct variation. How come? Because they both pass through the origin, right? They both get the pertinent information. Okay, this is our story problem. We're going to go ahead and read this story problem quietly to yourself, and then we'll figure out the important information that we need to write down, all right? A number of seconds, and we're going to do those 3 together. Okay, so it says here, as you watch movies, 24 individual frames flash on the screen every single second. How many of you knew that? How many of you knew that, right? It takes 24 frames for every single second. That's a lot, right? So if you think about like a 2.5-hour movie, how many frames is that? That's a lot of frames, right? We're going to talk about this. It says that there are 3 ways that we can model this situation, okay? The first way we can model it is with a table. So this is the part we're going to write down, okay? The first model is we can model this with a table. And what we're going to do is we're going to create a table here. And we're going to create seconds to number of frames. All right, we're going to create seconds to number of frames. Okay, so the first way is modeling with a table. All right, so let me ask you a question. After 0 seconds of watching the film, how many frames have you seen? You've seen 0, right? Okay, good. After 1 second, how many frames have you seen? You've seen 24, right? After 2 seconds, how many frames have you seen? You've seen 48, right? And after 3 seconds, how many frames have you seen? How many? 72? Or 90, how much? If I add another 24, how much would that be? 24, 72, right? Okay, 72. And the list goes on and on and on, right? This, after all, we're just talking about seconds. So that's the first way. The second way is we can use direct variation. All right, and we know that we're gonna have an equation that looks like y equals mx. You guys with me on that part? Okay. And the reason that I know it's direct variation is because that's at 0 seconds, that's at 0 frames, right? So y equals mx. Well, how do I get the slope? How do I get the slope? What's that? How'd you know it was 24/1? If it's 24 frames for every 1 second, there you go. So y is equal to 24/1 x, right? So now I have a direct variation model that I could use to represent this. And the third way is I can use a graph. So these are the 3 ways that we have here. A table, I can use direct variation, and then I can make a graph. So here's what my graph would kind of look like here. Right? It's direct variation. This is going to be time in seconds. And then this is going to be number of frames. So that's 1 second, 2 seconds, 3 seconds, 4 seconds, and so on and so forth. And these are my frames. How do you want to scale the frames axis? 25? 24s? Okay, all right. So 24, then 48, then 72. What's after 72? What would it be? 96? Okay, good. So my direct variation after 0 seconds, I've seen 0 frames. After 1 second, I've seen 24 frames. After 2 seconds, I've seen 48 frames. After 3 seconds, I've seen 72 frames. And after 4 seconds, I've seen 96 frames. You guys with me on that part? Yeah? Okay. Then the question I have for you, here's the question. One of my favorite movies is The Dark Knight. Okay? And that movie is long. That movie is 2 hours and like 31 minutes. Okay? 2 hours and 31 minutes. The question is, how many frames did I see? How many frames have I seen if my favorite movie is about 2 hours and 31 minutes long? Okay? Right now I want you to work with your partner and figure out what it is you think you'd have to calculate to see how time. So let's discuss it really quick. Okay? We're running out of time, so I want to bring us back. It turns out, The Dark Knight, we looked it up on Google, and it turns out that The Dark Knight's 153 minutes, so I was off by 1 minute. So we corrected our error there. Okay, how did you figure out how many frames did we look at here? What'd you look at? Morgan, what'd you do first?
Okay, so there's 60 minutes in an hour, so it's 10 to 50.
So there's 60 minutes for every 1 hour. Okay, so what does that mean?
153 minutes.
So we have a total of 153 minutes total on The Dark Knight Rises. Okay, good. Then what?
I times that by 60 to get seconds.
He multiplied this by 60 to get the seconds. Do we guys agree with that?
Yeah.
Okay, if there's 153 minutes, each minute is 60 seconds. You multiply by 60. So what'd you get?
91,080.
91,080. So 91,080. Is that right? Now, okay. So there's 91,080 seconds in this film. Is that correct?
Yeah.
And okay, then what'd you do?
And then times that by 24.
And then you multiply this by 24. Why'd you multiply that by 24?
To get the frames.
To get the frames. So what'd you get for an answer?
220,320.
320. Okay, who agrees? Put your hands up. Total frames. That's a lot of frames. That's a lot of frames. 220,320 frames that you've seen from watching The Dark Knight. Yes?
Did you see The Dark Knight Rises?
I sure did, yes.